So, dear students, we can get ready for our lesson. Can I make roll call to know who is getting started with me? So who is there? Who can be able to see that screen?
Yes, I can see the
Who is
screen.
able to see the screen? Okay. So when we come to
see the screen.
Yeah, thank you. So when we come to mathematics A level, it is divided into two papers. So we have paper one, which is pure mathematics, and then we have paper two, which is applied mathematics. So for today, we are going to look at applied mathematics. So are there some of you who know which area pure and under applied mathematics? Praise. Areas, you know, which fall under applied mathematics? Rogers?
The numerics.
Yes.
We have numerical methods.
We have numerical methods. Thank you very much. Another one?
We have mechanics. Then
We have mechanics, we have
statistics
and then
and
statistics
probability.
and probability. Yes, for today, our focus is going to be major on probability. And if I may ask, what do you understand by the word probability? Yes, students, what do you understand by the word probability? Before we proceed. No idea? Okay, so in probability, we can say in simple terms is a chance of something happening. So when you sleep, when you wake up, so there is a probability that you might wake up or you might not wake up. And then when you are to go to school, there is a probability that you might go to school or you might not go to school. So all those are events that happen in our life, and this part falls under applied mathematics because we apply it in our real life. So that is why they are under probability and then applied mathematics. So that one, okay. So we go to probability theory. So we said probability is a chance of something happening. So who can read for us that first statement of sample space?
Sample space, this is the set of all the possible outcomes, and each possible outcome is called a sample point. For example, when we are tossing a dice, we have the sample space of 1, 2, 3, 4, 5, 6.
Yes, thank you very much. So a sample space, we are saying it is a set of all the possible outcomes of an experiment. And we are saying each of those outcomes is what we call a sample point. So also we all know that a die has 6 sides. So when we toss it once, we expect to see a 1, a 2, a 3, a 4, a 5, or a 6 appearing. So from that set, what are the sample points? Because we said each one of them is a sample point. So what are sample points from this set we are having? Florence, what is our sample points? We cannot hear you. Okay, Ahmed, what are the sample points given this set? We seem not to be getting from him. Rachel, what are the sample points? Rogers.
Okay, sir, the sample points I see is from 1 to 6, so it is between the range of 1 and 6.
Range of 1 and 6. So each one of them is a sample, is the sample point. Then when we throw a coin, what would be our sample space? When we throw our coin, what would be?
The sample space will be 2, head and tail.
Talking microphone is muted.
Marta, ina mari ku soo saaray. Ina mari.
Who can read for us? Our next set. Ahmed, can you please read for us the next statement about a subset?
A subset of a sample space is called an event. The probability of an event is given by
Yes. Unstable.
Dabar farantaanyo lugahan
So we are saying an event. So I'm saying a subset of the sample space is called an event, as one of us read. And I'm saying its probability is given by number of events divided by number of the sample space. So we can continue. So we are giving it a summary here. And we had explained it that it is the probability of an event E is given by number of events. So when we add them up, divided by the total number of the sample space. So when we abbreviate it, that is how it will look like. Probability of E is equal to number of E divided by number of. Who can read for us the next statement? Probably those who have not said anything. Hello, class.
It says that probability of an event E is given by number of events or number of the sample space, which is number of the event, which is abbreviated as number of E. Number of sample space, one event ranges between 0 and 1.
Yes, so all the probability values we are going to deal with in this probability theory, all those values range between 0 and 1. So that means we cannot have a negative probability, or we cannot have a probability that is above 1. So all those values must range between 0 and 1. So that is a simple abbreviation of it. So we say it begins from 0, 0 less or equal to P less or equal to 1. For that case, our P stands for probability. Then we come to how do we generate our sample space. So we had seen the sample space. So you can read for us the first method that we use to generate a sample space. Who can read for us this?
We can use a tree diagram.
A probability tree diagram. Then we can also use a table of outcomes, and we also have permutations and combinations. So there are majorly 3 methods that we use to generate sample space. So we use a tree diagram, a table of outcomes, and then permutations. So we are going to begin with the tree diagram. So there anyone who can briefly describe for us how a tree is? Somebody to describe a tree before we proceed. Ahmed?
A tree starts from, shall I describe a normal tree?
Yes, a normal tree.
So a tree usually starts from a region, a fixed region, and it starts spreading
Yes.
with the branches going in different parts.
The branches going to different parts. Thank you very much. So, yes? You are saying something?
Me? No, I'm done with that.
Okay. Now, that is still the same with probability tree diagram. So we shall begin from a single point, then we shall branch. So we shall give it branches as we continue, depending on the nature of the question. So maybe you can say, so here we are saying tree diagrams can be used to obtain possible outcomes of an experiment carried out a number of times. So who can read for us that example? Who can read for us?
A coin is thrown twice. List down the possible outcomes and hence find the probability of obtaining one head and two heads.
Okay, thank
The
you.
probability of obtaining one head and two heads.
Okay, so we are going to go to our solution. So here we are having our starting point, which is here, and then our tree is having two branches.
Well, Benti.
So, and these other ones. So let me first fill in, then I get somebody to describe for us. Possibly those who have not said anything, can we have somebody say something? Nabu Kenya, can you say something about our tree diagram? Rocho, can you say something? Ahmed, can you say something about this tree diagram?
Yeah, in terms of
How we are building it.
how the surface
Okay,
area.
what you see in terms of what you are seeing.
You made two picks. You picked one head. You tossed the coin twice.
Yes.
So the first toss, we got either a head or a tail, on which we further toss, and in case we got a head at the first time, the second time we may get either a head or a tail. While the second, if we got the first time a tail, when we toss again, we may get a head or a tail.
Yes, thank you very much. I hope it is okay to others. Let's continue.
So if the surface area was 2, for the first toss of a head, it may be, if it was like one head and one, if the coin was having one head and one tail, the probability of the first head will be
Yes.
1 out of the total surface area, which will be 2. And also the tail of the first
Let
one
me
will
first
be a
correct
half.
you.
Yes.
Okay, so we don't call it a surface area. It is the sample space.
Okay.
So when we throw a coin or a die, so all the outcomes we get, we call them sample space. So it is the total which is sample space, not that what they are using, surface area. Okay.
Okay.
So in tossing a coin, we shall have a head or a tail. So since we are tossing it 2 times, then when we toss the second time, like you said, we shall as well obtain what you see. So our sample space will be when we write all of them. But remember, when we go back to our question was saying, let me briefly go back to it, that the coin is thrown twice. List down the possible outcomes and hence find the probability of obtaining 1 head and 2 heads. So we shall need to first list all the possible. So the possible outcomes, or what we given this. So everyone, I think here can give us their answers. Diana, what is the sample space here? What is the sample space? Ahmed, what is
The sample
the sample
space is
space?
2. 2. The sample space is 2.
If these
Yes.
other members could as well give us their answers.
Me, I'm saying.
Let me maybe take roll call.
Me, I'm saying, sir, the sample space is 3.
Yes. Kindly repeat your answer.
I'm saying that the sample space is 6.
Is 6. Okay. Any other answer? Any other person to give us their answer? Okay. So what you gave, a 2 and a 6 is the number. But not the sample space.
Yes.
So our sample space, we shall be interested in the outcome. Maybe if I threw at once and I got a head, and on the second time I got a what?
It.
A head. So my outcome there would be head, and head would be head plus another head. Okay. Now, this second one would be head
Yes.
tail.
Head.
So it would be head and a what? And a tail. Then when I come back to this one, I would have tail and head. So it would be tail and a head. Then when I come this one, it would be tail and tail. So when I write all these ones, this one, this one, this one, this one, then I, so let me again ask you, what is
4.
4.
Rogers?
4.
4 is the number. 4 is the number of the sample space. So what are the 4? What are the 4 that you are counting? What are they?
The
Are you trying
outcomes.
to get my,
Yes.
yes?
Yes,
Yes.
trying to get.
And any other?
The sample space will be head, head.
Get it. So here, my sample space, I would need you to write head, head, because that is what you get when you throw. One of the possible outcomes is that you can get a head on the first throw, and then you get another head on the second what?
Throw.
Throw. Are we there?
Yes.
So
Yes.
that is one possible what? One possible outcome. So who can tell us another possible outcome?
Head, tail.
Head, tail. Thank you. Any other? Another one?
Tail, head.
Tail, head. Then last, who? Rachel. Was it Rachel? Florence.
This tail, tail.
Tail, tail. So after this, we shall get our sample space here, which is S is equal to head, 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 tail, tail, head, and tail, tail. So remember in our question, we were asked to identify where we only have one head. So we shall come to our task where we have students. Please give us the answer because we can see.
The probability of getting 2 heads is 1/4. The probability of getting 2 heads is 1/4.
1/4. Getting yes, another answer from somebody. Ahmed. Probability of getting 2 heads.
The probability of getting 2 heads is 1/4.
1/4. Anyone with a different answer? Okay. Yes, Florence? Okay, I think let's continue because of time. So we first come back to this sample space here, and we pick only those where we have one head. So when we get there, we can see that we have a head here, a head tail. So there we have one head, and then tail head, we also have another head. So we shall bring them and write them here, head, head, and then tail, head. And then after that, we shall say now that probability of getting one head. So we count the number here, which is 1, and then this is the second one. So those will be 2 divided by the number here. This is 1, this is 2, this is 3, and this is 4. So the number of sample space is 4, and the number of the event, which is one head, are 2. So we shall get 2 divided by 4. So when we divide by 2, it gives us 1, and by 2 here, it gives us 2. So that is why we have our final answer as a half. Then if we continue, I've given you the answer already. But now, because of time, let's do that. So probability of getting one head. So we shall come back of getting 2 heads. So here we shall need that when we throw, we get a head. And when we again throw, we get another head. So this will be only a head. So we shall pick it and come and write it here. So the number here will be equal to, of course, it is a 1. Then the probability will be equal to 1, which is the number of the event. We divide it by the sample space. Their number, we had seen that it was already what? A 4. So that probability would be 1 divided by 4. Is that? To ask, you can ask the left. So we can ask the questions, then I respond to them. And then we call it a day. Come, sing a hand from Rogers. Rogers?
Sorry, it was by mistake. It was mistake.
It was by mistake. Okay.
This screen.
Any questions, please, in case you have something to ask? So if people have no questions to ask, so if you have no questions to ask, let me ask, how has been the lesson?
The lesson was being nice. It has been good. At least we have picked up something.
Thank you. Thank you. Ahmed, how was the lesson?
So it is good, and we are understanding as well as benefiting a lot from your lesson. Thank you.
Thank you. Florence, how was your lesson?
The lesson was good.
Lesson was good. Diana, how was the lesson? Okay, since most of us, so let me request somebody from the Ultimate Media, somebody hosting our meeting, our class, to say something. Bernard? Mr. Bernard, can you say something? Okay, to our dear students, so I think they are going to send you a form to fill. So make sure when you receive that form, you fill it, because we want to get a feedback from you of how the lesson has been, and possibly what we can do in the near future to make our lessons more interactive and more benefiting to you. So make sure when you receive that form, you fill it and we get feedback. And we would love to see most of you enrolled to our product, which is Yaaka, so that you have more of these lessons, because we always have these lessons. In case you have enrolled, we conduct these lessons on a weekly basis. So you'll be in position to get these lessons in your combinations every week. So we have content that is prepared, so which is already waiting for you to consume. So we have that content ready. So you go through the content and then you come to the live classes like we have done when you have gone through that content. So I wish if that is done, so we shall be meeting more and discussing more, and you'll be enjoying more of these lessons. As we wait for our hosts to say something. Yes, Dana, do you have something to say?
No. No.
Okay. How was the lesson?
Best at first I was not understanding, but at last I have understood what was going on. Yeah.
Okay, thank you. So when you get that form, you fill it in.
Yes.
Okay, thank you. That's good. So Mr. Bernard, are you there? So which combinations are we taking? Because some of us didn't say something about our combinations at first. Okay, so I think our time is going up, so we can leave the meeting. Then when we receive that feedback form, please fill it in and